You can download the slides at this link if you'd like, or take a picture right now so that you can get them. I recommend doing that, especially now since we transferred slides and I don't know how it's going to render, but also when you're on your phone or your laptop, I can pretend you're paying attention to me instead of Slack, and it gives me an ego boost that I so desperately need. All right. Let's hope the clicker works. While I'm waiting on that, yeah, this isn't going to go my way today. All right. Okay. Before we actually get into the meat of the presentation, the technical pieces, we're going to go through a few things that's happened recently. So the first one is one login. Anybody heard about this whole one login breach? Cool. So, as you can see from the quote, stolen access keys or somehow otherwise obtained AWS access keys resulted in a breach. And then somebody decided to put some confidential stuff out there on the internet on AWS without doing any due diligence. And that's another recent one. This is a Q-Ora thread. I always like to point to it. The title is $50,000 lost, but somebody lost $285,000. And this is, again, through a compromise, through a breach. Somebody got access to the account, started spinning stuff up, spent a bunch of money. And this one I laugh at. But I had an NDA. He still disclosed my code with access keys in it. So that's just sort of a few examples of things that have happened and I think make this talk a bit more relevant. So I'm Ken Johnson. I'm the Chief Technology Officer at Visium. We're actually in Herndon, Virginia, so outside of DC. As the Chief Technology Officer, I do a lot of engineering and I work with AWS quite a bit. So my concerns are that we're a security company that runs on AWS, and if we get hacked, that's really bad for us, right? Reputation, loss of confidence, things like that. So, and I can actually give you a story real quick. So I was driving through West Virginia on a Sunday. The best thing I can say about West Virginia, it's not Maryland. So I'm driving through West Virginia on my way to Ohio, and I'm supposed to be taking a couple days off with my family, and I get this panicked call from the CEO. And I guess somebody on Twitter in a language we don't speak said something, I think it was Portuguese, said something about, I have something to report to in Visium, or something along those lines, roughly translated. We used Google Translate as best we could. So it is what it is. I'm winding down 25 miles an hour in the back hills of West Virginia, trying to get out of there as fast as possible, and also trying to sort of work with this incident response process, I guess you would call it. And I came to the realization once the day was over, and by the way, how this ended was, it was somebody in Brazil who wanted us to hack a website they felt was I don't know, they had something against the site. So that's what the whole Twitter thing ended up being about. So we weren't hacked. But at the end of the day, when we did a recap, one thing I realized was I don't have a lot of visibility with AWS, and I really don't know much about it in terms of how to harden it and how to really go back through. Well, first of all, get real-time events on things when they occur, and then also go back through if something has occurred and actually figure out, what's going on. This talk is primarily about preventing super preventable things that, like stolen access keys or somebody posting them to AWS or to GitHub. That's the actual, like a key being leaked is not a big deal if you follow some of these things that we're going to walk through. In my experience, account exploitation or AWS account exploitation occurs through primarily three ways, and also not just my experience, the news, right? So vulnerable systems, that means an application with command injection hosted on some EC2 instance, or unpatched and has some security groups open. Or somebody, like I said, leaking credentials, or them being retrieved otherwise, or just misconfigured services. Someone taking a stab in the dark at, doing a showdown search, which we'll show, looking for something along those lines. A misconfigured service. Still not working. All right, I'm giving up on the clicker. Exposed credentials. So when you operate with the AWS API, this is where credentials are typically stored on your machine as a developer. And for those of you who are like red teamers and pop a box, this is where you want to go. Y'all are a bunch of animals, poor developers. So doing a little search on that note on GitHub, just for like one of these files, thought, hey, let's look for it. Oh no, access keys, right? And by the way, I have so many screenshots of this, I'm actually gonna just limit it, but here's another one where it's just in source code, right? So you can use GitHub's advanced search to find these things, or you can just use code search, which goes through GitHub and it goes through Bitbucket and wherever else it searches to find those keys. For misconfigured services, so a good buddy of mine, Chris Gates, Carnal Ownage on Twitter, I'm giving him some credit here. We've actually been working through some attack tool sets for AWS as well as some defense. And one of the things he started doing was let me enumerate buckets that exist out there on S3. Pretty simple, and it's not really like a super novel idea. But what's interesting is if you find, and you can see here, it's like, oh, you know, it doesn't exist or you don't have access. You know it's either there or it's not. And what's interesting is when you go to list one of those buckets that you shouldn't have access to, right? What we see here when we're running this AWS ls command on the bucket is that we're just providing our AWS account credentials. Not, and this is the pivotal part of this, is that there is a permission on AWS S3 that if you say, hey, allow authenticated users to access this bucket, it's not authenticated users for your AWS environment, it's for any AWS environment. Yeah, a lot of people. Actually, and we reported it to this company, by the way, but like I said, we were doing some research and we found that, hey, if I just, yeah, this is cool to list, but then you can go in through the web console and you can actually upload as well. So I just navigated to the bucket, uploaded a text file, let them know what was going on. And luckily, the only reason we knew who the company was because of the way the folder was named. So this is just, probably doesn't show up well, doesn't matter. It's a Shodan search for Elasticsearch. Basically, you can search on Shodan for any of these AWS services and find them open, exposed. Not, right, it's somebody who just misconfigured and didn't lock down the security groups or didn't lock down that service in some way. But this isn't the only example, right? I've got plenty of examples for open RDS. I have screenshots of, and I didn't put it on here because we had a lot of material to run through, but I've got screenshots of RDS, which is a database service within AWS where people were using default credentials, weak credentials, and then just leaving it exposed to the internet. But yeah, the list goes on of bad things that people do. In terms of vulnerable services or vulnerable systems, the way that this works is system's vulnerable, cool. We've gotten on the machine. Now this is where it gets interesting because on the machine, there is a place I can navigate to get credentials, and then based off the access of those credentials, I can pivot throughout the network. And if you're ever curious about how often do EC2 instances get compromised, just Google. You'll find your answer. So this is the URL on these machines that you would navigate to. And this isn't just EC2 instances. These are just any instances that actually use STS, or security token service, or a role attached to the instance. So you obtain your credentials here. You pivot through the network. And there's a talk on this from 2014. And there's also a tool, Nimbostratus, if you'd like to mess with that. So the summary is of all this stuff is there's like plenty of ways to get in. People are making these mistakes, but it's all really preventable. All right, so we're going to show monitoring, we're going to show hardening, and if we have time, open it up for Q&A. So monitoring, there's 3 services within AWS that allow you to monitor. You've got CloudWatch, Config, and CloudTrail. We're going to cover CloudWatch and CloudTrail in this presentation, but I have a link to the config, to a talk where I show how to set up config and how to use it in this slide deck. So CloudTrail, this is sort of what it looks like. There's a web console, there's API, whatever way that you're interacting with AWS. If you're on the website, if you're doing whatever. You trigger an event and you access something. And we've got, what is this? IAM, I think Dynamo, just any service on AWS. And then that gets put into CloudTrail. And those logs can then be parsed by config, CloudWatch, or anything else that you'd like to use to parse and analyze and do something on those logs. And it's really easy, just turn it on. Super simple. Go to CloudTrail, turn it on. And you configure a log group. And it's going to ask you, can I create this IAM role? Of course you can, AWS. Create the IAM role. Now, that was CloudTrail, and it is really that simple, so it's not we don't need to spend a ton of time beating that into the ground. CloudWatch, on the other hand, I think this is part of the interesting section on monitoring, because CloudWatch has 2 different features, alarms and events. If you use CloudWatch alarms, this is what you get. This is the information that you get. You know something bad is happening, but you don't know much else. This is where we want to get to using CloudWatch events. We're going to walk through how to get like the event ID. So you can go back through your logs and do some incident response. You get to source IP. In fact, you could go a bit further and maybe have a group of source IPs that are trusted, and if something happens and it's not within that list, you can react in some way. This was a pain, and this is why I'm sharing this information, because has anyone ended up with like 30 tabs in Chrome or Safari just trying to figure out AWS documents? Yeah? All right, cool. Not just me. So you won't have to do it for this. So first, I'm going to show you setting up a generic alarm for unauthorized activity, and then we're going to go into showing a little bit more granular depth on how to get more information from CloudWatch. So one thing I'm going to point out, though, is it's not I'll use alarms over events, or it's use both, because alarms will trigger every time, and because of the way that AWS has parsing set up and their events structure set up, so it's JSON. But depending on the source event, depending on the version of the event JSON blob coming to you, it could look a little bit different. And that means that whatever you're using to parse can fail. So it's a 90% solution on events, and I would say that when it comes to the alarms, it's 100%. You never see any issues. It is what it is. So in creating the alarm, you go to the log group that you would like to pull logs from and analyze, and you create a metric. And then you define the pattern that you'd like to grok for. It's whatever you think. In this case, it's an error code of access denied and unauthorized activity. And so if that pops up in an event, you get notified. And you give it a naming convention and some of the sort of standard stuff that you do. And you go to create an alarm, because once that's set up, once that metric is set up, you will create an alarm on that metric. Give it some information. In this case, we say, hey, if this happens once within like a 5-minute period, do something. So one of the links I have shows taking this alarm where it triggers and pushing it to SNS, and you get an email and all that good stuff. And I'll point out which link that is. So it works really well, very effective, but again, the data is not very useful. This is what an email, so using that alarm and it pushing to simple notification service within AWS, which allows you to email, text, whatever the case is you'd like to have SNS do. In this case, an email, this is just the information we got, which is you set a metric of 1.0 and I'm a robot and a machine and you exceeded that, and that's not helpful. We know something bad happened, we just don't know what. So then rules. Apologize, that renders a little weird on this laptop. But the basic gist is if something happens, what we're going to do, the steps that we're going to take here is if an event happens, we're going to send it to, if an event matches a pattern we're looking for, we're going to send it to Lambda. Lambda is going to parse out the data that it needs, and it's going to push a Slack notification out to our team. So this is how it works. You go to CloudWatch, and you go to Events on the left side. And then this is, by the way, the JSON blob that I was talking about, and it can look different, like I said before. And this is going to be parsed and caught. What this all kind of was based off of is this link where it said, hey, look, if we detect an event where someone's trying to do something like add a user and they don't have access, we're going to check and see if they're an admin, and if they're not an admin, we're going to revoke access. And that's pretty cool. It's just not really what we want. It's not what we're looking for. We're just trying to monitor, not revoke access. So this is the part where we actually walk through the meat of this, the Lambda and Slack integration. There's 3 parts to it. We're going to configure a webhook within Slack. We're going to use KMS, which is Key Management Service, to actually store this sensitive webhook value. And then we're going to create a Lambda function that can basically decrypt that KMS value to get the webhook URL and then send information out from Lambda to Slack. So you'll configure the webhook in Slack pretty easy. Add the configuration. There's some other stuff you can do here, like a cool picture, or give it a nice name, and then tell it what channel you'd like this information to be posted to. Retrieve that URL, and then go into KMS and create a key. Really, at this point, what you're doing is you're saying, I'm kind of creating a repository inside of KMS where that key value pair is going to be stored. So you're not putting the value in right now. You're going to do that in the command line. So you give it a name, in this case, Slack Alerts. That's the alias, and that's important because in this screenshot, this is the basic breakdown of what's happening. We're giving it basically the webhook, which is it's blurred out. I'm not going to give you my webhook. Fair enough, right? So we're telling it that it's the STS profile. I wanted to point out that I'm telling it it's the STS profile, so I actually am using security token service, and we're going to talk about that when I get to the API and multi-factor authentication, but I'm doing my due diligence here. And then the alias part, which is really important, we're passing on that it's the Slack alert. So this is what's going to happen. We're going to provide it this webhook. We're going to tell it the repository, the key on KMS we want to use. It's going to give us back this big blob, and what that blob is, it's base 64 encoded, and if you were to decode that, it's actually an encrypted value. We're not relying on like base 64 to encrypt, right? So that is normalized, and you can plop this into Lambda and be on your way. So the Lambda function, you can just create a blank function with no template, and then go in and follow the next step. Just don't worry about the trigger, just hit next, and then use this code. So I'm giving you the code on how to parse events and actually send this is just for the unauthorized activity. Somebody's doing something they don't have permissions for. But still, it's something you can use, right? So modify and tweak. So there's where the code's at. Plop it into that Lambda function, and you're going to choose, you give it a name and all that good stuff. And this is the role. This is where you choose the role, and you have a role that basically allows that Lambda function to decrypt that KMS key. And I don't know if I showed it, but the important part here inside the code, and again, very blurry, but there's 2 pieces here. One is that big ciphertext blob that I told you about. You're going to put that in there. And then the other piece is you just put the channel in Slack that you want it to go to. And then again, choose the service role. So when it comes to going back to CloudWatch and events and actually setting this up, one thing that I beat my head against the wall for like way too long was figuring out how to change this event source, because my problem was the events, Like, I want an event for everything. I don't want an event for just IAM, somebody doing something in IAM, or somebody just doing something in EC2, or whatever the case is. And I'm embarrassed to say that I missed the directly edit the file link there at the bottom, but I'm going to point it out so you don't do the same thing. Because when you click on that edit link, you're allowed to go in there and actually just modify the raw JSON. So in our case, we gave it an error code, and then we said, we gave it 2 items inside of an array, and basically we said, hey, if it's any one of these error codes, this is what you're gonna trigger on. And then we told it, on the right side, we said targets, and we said, hey, if you get an event that matches that, send it to that Lambda function. Okay, so, and then just finish it. That's it. So when we go to test, and we have a user that shouldn't have access to actually create users, we get this notification in Slack. So we're really happy, and everything works, and life is good. Awesome. So I hope that has helped folks in this room in some way. I'm going to move on to the link that I mentioned earlier. So this link that I mentioned earlier, this has basically the things that I tell everybody to set up at a minimum, which is, hey, if your billing usage increases overnight, like, you should have a threshold and get an alarm if that threshold is exceeded. And failed login attempts, definitely want to know about that. And then root account usage. So we are going to talk about root account usage here shortly. But yeah, I definitely recommend checking that out for a little bit. And also config is talked about in that video. So for hardening, it's crazy because AWS provides all this information, but I just don't see it used very often. And there's a whole framework on doing these things, the security fundamentals. And there's a CBT, a free CBT on the kind of the high level of AWS security. So our checklist is don't use the root account, audit your policies, enable multi-factor authentication, enable multi-factor authentication on the API, and we got some miscellaneous stuff in here. And depending on how much time we have, there might be some add-ons. So AWS root account. Every AWS account has one. It is the king account on there, right? And you should only use it when you absolutely have to. Do not use it as an operational account. We see this used as an operational account far too often. And there's a reason for that. So in the video I referenced, when we talk about setting up the root account usage alarm, on my team, I can tell you how it works. If somebody has not told one of us that they're going to use the root account for some specific reason and we get this alert, we freak out. And that sucks. And everybody's kind of like, it doesn't matter what time of the day or night it is, you're gonna hear about it, right? So you should have an alarm for it, and you should have a limited use case for it. Auditing IAM. So this is the craziest part of AWS, in my opinion. A single user can have inline policies, managed policies, belong to groups, who then have inline policies and managed policies. Painful, very painful. Managed policies are just policies that can be attached to multiple users groups, et cetera. And inline policies are just something specific to that user role, whatever the case is. And I've seen these conflict with one another too, which is fairly interesting. So I gave a tool here, it's a little script, and it creates a CSV file and allows you to see what these policies give a user access to, and it dumps out their username and all that fun stuff. And here's sort of what it looks like, and I can zoom in there. That's a lot of information, and this is only like 6 or 7 accounts, and these accounts are basically real. It's scrubbed, but this is real data, and also limited to just 7 people here, but it gets insane, especially when you have like 100 users. So that tool should hopefully, in theory, help you. But one thing that happened since I actually wrote that script was AWS. And this is, by the way, anybody who works on AWS knows, if you build something for AWS, wait 6 months because they're going to build it for you. It's a painful thing. But anyway, so if you go to this link, they have many more pretty screenshots and directions on how to get basically a beautiful breakdown of what a policy gives access to, what type of access, what resource, etc. So it's pretty nice. Why is this important? So I'm going to give one use case of why this is important that I saw before, which was pretty interesting. So we had a client, and they were like, oh, yeah, you know, we've locked everything down, and only specific people have SSH keys to these machines, and yada, yada, yada. So these machines actually stored PHI and PII. And all of these machines used unencrypted volumes. If you're not familiar with unencrypted volumes, the volume is essentially the virtual hard drive. And if it's unencrypted, it means anybody with access to spin up an EC2 box can attach that volume to that newly created EC2 box that they gave themselves SSH access to. Now they've got access to all that data. So this is one example of why this can be a little bit confusing, but you really have to audit access continually because the environment's elastic and it changes. And I don't know about you, but, and sorry if I'm offending any developers, but it really scares me that we've got developers basically pushing infrastructure with code. And all that hard work from the neck-bearded sysadmins are it's going by the wayside. So anyways, it's elastic environment, audit the policies, and figure out where your data is flowing and who might have access. For multi-factor authentication, this is pretty simple. Everybody in here knows about two-factor authentication. That's all it is. The only thing to mention here is you can do this through a virtual device, which is like an app, and you can use a hardware, which is just Gemalto piece of hardware. But what most people fail to remember is that while you can do this on the web console, it's most important to do it on the API. And this goes back to the first few slides in this talk, which was this isn't happening because people are obtaining credentials to the web console. It just isn't. It's happening because somebody's posting keys somewhere, and those keys are used to access the API. So while we're sitting here protecting and that's a good thing, protecting the web console via two-factor auth, I'd argue it's more important for or just as important, if not more important for the API. I'm gonna move this for a second, it's driving me nuts. Okay. So, to enable it, it's easy on account. You go to security credentials, you go to manage MFA device, and you choose whatever virtual or hardware that you'd like to choose. If in this case it's an app and we take a screenshot. And I think it's important to mention here, there's an issue with this though. And this is what we usually, so I'm gonna talk about the issue real briefly, and then I'll talk about the solution that people are using that I've seen. So the issue is you have to have access to actually manage IAM in some small way. And obviously, unless you're an admin, you shouldn't have that access. So the solution that I've seen people do is to take a picture of that and email it to their administrator. Or, sorry, the administrator email it to the person, and then the person sets it up that way. Awesome. There's another way to do this. Not so easy to read, so here's a link. Basically what it is you create this policy, tweak a couple things, put it on to attach it to somebody's account, and they can manage their own MFA device. All right, so if you need to share that root account for any reason, I do recommend 1Password. They use TOTP. That's what AWS uses. It's a widely used standard, and I like the service. On the API, I'm gonna kind of skip past some things here. So this right here, this policy on IAM, you attach that to a user, and this condition right here, this one line says, for both the web console and for the API, you have to use two-factor authentication. And this really sucks at first. It's painful, I'm not gonna lie. Here's some code to actually do this. I've heard a lot about people using HashiCorp Vault. I've never used it myself, but apparently this is one solution for this problem. But the code that I gave you a link to, this is sort of an example. It's Ruby code, and all it is you see that you give it your MFA device, you give it your access code, or sorry, your access key and secret, and you give it the MFA code that you have right now. You send that request off, and assuming the MFA code's still valid, you get a new set of credentials, which means a new access key ID, a new access secret key, and a a session token. So this is running it, and this is what I said, 3 different pieces of credentials you get back. And then to run anything, you just pass it in. Like here's an example of using the EC2 describe instance, and we pass in that those credentials, but that -t is that added token. And in case you don't like Ruby, which I get a lot of hate for being a Ruby coder, here's another bit of code that can help you out there. Elastic Beanstalk, it's awesome. I like to use it, but it doesn't use STS. So a workaround for that is code pipeline, code commit, and GitHub. What you can do is hook code pipeline into that repo to point at that repo, and then when a change occurs, it can be automated and pushed into the Elastic Beanstalk environment. So remember, MFA only protects you against the web unless you explicitly enable it for the API. All right, roles. Roles are awesome. They are not an IAM user. They give you permissions to access things inside of AWS like a user, but unlike a user, you don't need to like hard code credentials inside of source code for your applications. The basic gist here, and by the way, referring back to that URL where you went to that URL and you like exploited a box by grabbing the credentials from that URL, the double-edged sword here, because this is how STS works. But what I'd like to point out is I gave a few examples here, like the AWS SDK gem and the egg for you Python folks. What it'll do is, if you've got that STS role attached to that instance, that EC2, Elastic Beanstalk, whatever, it'll actually automatically grab the credentials off that box for you, and you don't have to put it in your source code. And if you are a Ruby person, use Fog, don't use Paperclip. All right, this is an example of a policy. It's hard to see, it doesn't matter. It just means that you can be very granular in what you give that role access to. And once you've created a role under the IAM within AWS, you just attach it. Literally just drag and drop, attach it to whatever you need to attach it to, in this case, an Elastic Beanstalk instance. So, miscellaneous stuff. Gave you some code here. This allows you to flag on any volumes that are not encrypted. And it also lists the ones that are encrypted. This is just a review of S3 bucket policies, so it just dumps out all of your policies. And I'm gonna go ahead and play a dangerous game here and go real quickly over some extra added bonus content. So if you've got Splunk, does anybody have Splunk? Awesome, so for you, well, first thing here, for you that are using Splunk, don't put it in the environment that you want to monitor. I think that's pretty much common sense. Same thing as like when I talk about disaster recovery, don't upload your AWS backups to the AWS environment. That's how code spaces went out of business. But anyways, for Splunk, the plugin that I like is the Splunk app for AWS plugin. It's the first one listed there. And it gives you all this information and you can alert on all this cool stuff, topology changes, billing, etc. Pretty screenshots, very cool. This is an automated topology builder it gives you. That's pretty cool. And basically, all it needs is an account that they give you at this link, the exact policy to give that account, and it'll be able to pull in most of this information. All right, so I'm going to go back and summary. Harden, monitor, do some of the basic hygiene for your AWS environment. And really, I do hope this was helpful for folks. The links to the slides are at the bottom here, and I guess we have time for maybe a few questions, if there are any. None. Okay, awesome. Thanks, everyone. Appreciate it. Thanks.